Hey, what's going on, everybody? Today is November 25th, 2024, and you're listening and watching the Daily AI Show live. And today we're coming at you with the beginning of Thanksgiving week here in the States. So businesses are starting to slowly shut down and disappear and and not respond to Slack and emails and all those good things. But we are going to be with you all week long, as we always are. So we have 5 new shows this week. Make sure you come back and hang out with us all week if you want to play along and learn AI as we do. Today, we have a really interesting topic. I've done some research on this one, and I'm interested to get into a conversation with you guys. I think it's just sort of a like, where are we on this? And the idea is, and Beth, you can do a better job than me here, but just to set the stage, the idea here is, as we think about how not just AI, the term AI, but neural networks are being trained, and this concept that came up about how these neural networks are being grown as opposed to maybe built or trained, and we'll get the right wording for that. And I came out of a conversation with somebody out of Anthropic that presents some unique challenges as well as potential for businesses, for a lot of people. And it goes into this idea of like this black box idea of like, how do you really ask questions? And so I have some stories and some analogies in my head that I feel like will help the conversation, because it helped me. You guys know by this point we've done almost coming up on 400 shows. Like, my brain just thinks in stories and analogies. So I will share those along the way with the audience as well, because maybe it'll help others conceptualize like sort of what we're talking about here. So I know I did a pretty horrible job of getting that started, Beth. So let me pass it over to you, because this certainly came out of a specific interview with a specific person. I just didn't have it on the screen as I was doing the intro. So I'll pass it over to you.
So it's a Lex Friedman interview. It's a 5-hour interview. I know sometimes that's frightening. This section, what we're talking about, is like a 5-minute part of it. And it's with 3 different people at or from Anthropic. And the third person that he talks to is a person named Chris Olah. And he is fascinating because essentially what his role is trying to figure out what's happening, right? And he makes a couple distinct points. The first is that artificial intelligence, the way that it happens, is more like a biological organism, right? It's grown more than it is programmed. And then, like, in the next paragraph, he talks about, but we're trying to figure out what the computer program is that we grew, right? But essentially, like, you could think of this like growing vines on a trellis. So they scaffold the growth, and he likened part of it to the light, right? So you can set something up that's scaffolded to give it the idea, I want you to grow in this direction, but then you have no idea how it's growing. And what is most interesting in this context is the unexpected ways, right? The unexpected skills and challenges. And it was funny because he references it all as an artifact. So I have to assume that's why Claude makes artifacts, because it's a Claude thing. It's an Anthropic thing.
Maybe he named it.
Right, right. And so this is just a really interesting it's just a really interesting change, and it's a conversation that I feel like I have with business people, and we fall into it sometimes too, where like, you do this, it should do this, because you're doing it in a computer and it's functioning like a computer program. But
Right.
it does not matter if it's wearing the costume of a monitor and a keyboard. That does not mean that it is a computer program, and it's not that kind of deterministic, right?
It's a good visual. I like the idea of the costume, the Halloween costume, and masquerading as as an actual computer program. Yeah, this will go. By the way, Andy joined us as well, so welcome, Andy. I'll bring out the first sort of analogy I have here, because as I was thinking about this, I'm like, well, what is this modeling? What is this mimicking? And of course, it's brain neurons and neural networks that we have, and how things are connected in our own brains. And so the analogy I thought about it, and then I sort of was was proposing this into Perplexity and saying, help me draw out some of the key ideas of this story, which, by the way, is a great way to, Beth, you're always talking about brainstorming. Use AI to brainstorm. Like if you have ideas, if you have partial ideas, if you have half-baked ideas, which are most of the ideas I have are like partial ideas, use AI to help you formulate it in a way that's going to maybe be more helpful for your audience, in this case the show, right? So my thought process was, okay, the setup is you have a child, any child, pick a child, and that child has learned, think of a child in your head, like any child. You have a younger child, I'll say, like pre-adolescent, and you have a child and you say, hey, do you think this is true or false? This thing, this question. And that child, assuming it's age appropriate, right? That child is going to say, I don't know, or maybe because my teacher told me it was. So let's use the question, hey, 6-year-old, why is the sky blue? You're going to get some sort of answer to it. And that child may just ham up and ham up and just say, like, I don't know, my teacher told me it was blue, or my parents told me it was blue and it's blue. That's what I know about the sky at this point. Or they may give you a more detailed answer, depending on if they maybe have a love for science and they've started to get a little bit older and understand light reflection and refraction, all the things that make the sky blue. My point is this: if you can ask the question to the child, but if you turned around and said, why do you know that answer to be true or false? That's where it gets tricky, because now you're basically asking in basically a summary of a sentence from a child or even somebody older than that to take perhaps thousands or millions of different points of data for that child all the way up to that question. And then you're asking for a very simplistic, maybe sentence answer on the back end of that, of where it is. Also, it really depends on the question you asked and how it was asked to the child. That also is going to drastically change maybe how they turn around and give some sort of answer. And so this is the first story or analogy that I'd bring up to you guys, is this idea of it's difficult because the understanding of why is baked into perhaps thousands of different impressions, thousands of different like data points. If you can think about that in our minds, a child is growing and connecting and growing and having new neurons and adapting new neurons and connecting them in all sorts of fascinating ways that are unique to that child, at least to the point that no other probably child, even a sibling sitting in the house, is going to have the exact connectors. And so if you were to go back and say, well, how do you know that that's the answer? Where did you get that from? What informed you in making that decision, right or wrong? Where did you arrive at that? It's a bit of a black box, because you could imagine even if you did this for hours upon end with an adult, you might get all sorts of different answers. And that in lies the problem, is it's a bit of a black box, because you say, well, how did you go about making those connections? And the model kind of goes, I just did, because that's where my connections were. And that to me is this first idea of, like, when you talk about growing a neural network, you're going to get the benefits of that, of its self-learning and making connections on its own. And you're going to get the problems with that, which is, hey, how did you get there? And is there potential inherent bias or built-in bias into that, and some other ethical issues that may also be a problem? So I'll stop there, because Jimmy, Andy, I would love to get your feedback, but that's where my brain went first with this. And then I have a business one that I could talk about later.
Andy, would you like to go next?
Okay. I was waiting for Jyunmi, but
yeah, me too.
Okay, I thought this was a really interesting exercise to discuss this idea of growing models. We've talked long ago about the idea of evolutionary model merging, which is a kind of selective breeding process for LLMs that mirrors processes in the world of horticulture. So I did a little exercise that I'll move to the creative aspect of it in a moment. But here's just some broad ways that building and improving LLMs mirrors the process of horticultural development. So first you have seed selection, right? The seeds are the foundational data sets. And then you have nutrient inputs, and setting up the environment in which the model can learn and grow. So plants require a balanced mix of nutrients, water, sunlight, and language models are also fed a carefully composed diet. There's power, there's attention mechanisms, and there's textual information from diverse data sources. And that all kind of contributes to the model's cognitive growth. But importantly, you have to prune and do selective breeding. So this is a really interesting parallel with it, which is, in an LLM, you prune the toxic or harmful content branches. And that's where the model researchers actually go in and they kind of cut off certain elements of the representations in the model as it was trained. But, the best way to avoid that is to really carefully curate the data that goes in there. And it's been demonstrated that by really husbanding the process of selection of data, you get to a much better result in a model. You can trim low quality information pathways. So here I found out that by adding this data, it just kind of confounded the intelligence of this particular model. And then, of course, we talked about grafting new knowledge domains onto existing ones, right? So you have a mixture of experts. This particular plant model that I grew has expertise in this area. And if I merge it with, not merge it, the wrong term, if I mix it in as an element of a larger deep neural network, then I have a highly specialized capability that's been added through this grafting process, literally, plugged into the other one. And then, Beth, you were talking about these emerging properties that are a part of something that you don't have deterministic control over. And just as a mature plant, can develop unexpected characteristics through genetic errors, if you will, that turn out to be either beneficial or harmful. You have these emerging properties. So this complex interaction in an LLM among training data, model architecture, and computational processes gives rise to novel capabilities. And if you can identify those and identify how they ended up in that model, then that adaptive trait that was demonstrated by the model can be applied to new models. So then the creative part of this one was, I said, it occurred to me that, there's a Peter Sellers movie called Being There, which is about a gardener who stumbles his way into being a major political commentator on a television network. And they're asking him questions. And the president, it's in the context of this gardener being in the president's household. And so then there were all these quotes that he would give in response to complex questions that he was given, but which oddly, really provided comfort and direction to the people who were asking the questions. So I had Claude generate a few of these things for our entertainment. So in the garden of intelligence, some data grows, some withers, but the model always knows how to turn towards the light. And that actually refers to a capability of the models, which is driven by the loss function, that allows them to figure out what's better and what's worse and to turn towards the better. Okay. Pruning is not destruction. It is renewal. What is removed makes space for more purposeful growth. Some data are like weeds. They look like knowledge, but they choke true understanding. A wise gardener knows the difference. And there's 11 of them there. I won't go on, but it's really fun to think of like gardening your LLMs. And eventually, we will, as individuals, be able to take open source models and create a garden of them, right? We'll have a selection of them, each of them with different combinatorics of the capabilities that have emerged within LLMs.
Yeah, I wish Carl was here for this part. I don't know, Jimmy, maybe. Well, I don't know if anybody else. I just know Carl talks about blockchain quite a bit, and I'm definitely no expert there. I learned a bit when it was bigger in the news and stuff a couple of years ago during the pandemic and stuff. But really what I took out of the idea of blockchain is this idea that it's a good combatant against fraud when you're checking things on the blockchain, be it, let's say, in the future, I think all mortgages will probably be run through the blockchain. And this idea that you have many decentralized people checking and validating information. And the idea being that as it goes through this very complex process in the blockchain, that it's in effect saying, well, at any one point during the process, if the information was changed, it would have been caught through this decentralized process. And that's why it can be a very powerful way to combat against misinformation or stuff like that. So that's a very overly simplistic thought process of blockchain. The reason I bring it up though, is when you talk about mixture of experts, Andy, and then I want to get into this, get your guys' thoughts on a term that was brought up that I've never heard before the video clip from the Lex Fridman, is mechanistic interpretability. I had to make sure I said that right. It's like interoperability, interpretability. And that was a term that was brought up quite a bit. I was like, okay, what is this? Let's go figure out what this term is. But this idea of, maybe the one potential solution here, as you're giving this analogy of tending to the garden, and the idea of removal or pruning not being necessarily a bad thing. It's actually a good thing in order to get the garden to continue, or the flowers to continue to grow towards the sunlight, right? Turning the plants, so whatever, that kind of thing. This idea of examining it, and then maybe potentially with mixture of experts saying, hey, that we don't always know, or perhaps we won't always know why the neural network chose this path. But what we know we can do is deploy many of these neural networks. And perhaps that one potential solution towards fighting against bias and other ethical problems that might get inherently built into these neural networks is to actually have many of them and have the ability to cross-reference against them, so that if one particular neural network is erring and is turned away from the light, to use your analogy, Andy, that the other ones would help it correct backwards towards the answer. So maybe that particular neural network has not changed, but because we have the ability to apply many experts towards this particular potential solution, that we might be able to solve and ensure that we don't get bias or other issues going into it. At least that's kind of where my brain was with this, is like, how do we apply all this together to combat an inherently hard problem, which is like, how do you dig into somebody's brain and say, where did you get that from? And then you go, oh, okay, well, when I was a kid, my mom smacked me one time, but I deserved it because I was eating, poison berries. And you're like, oh my God, we're starting when you were 4. And you're like, well, that's where the story starts. It's like, okay. How are we going to connect all this? You're like, that's how it connects. I don't know what to tell you, So like, how do you dig in there? How do you get in there and get these answers? So anyway, I'm rambling, but that's where my brain's going.
Yeah, there are research efforts and in certain centers of excellence that are looking into how do you determine which part of the neural network contains or represents, for the technical term, representation is what's created through the weights in a certain area within the model. How do you identify where that is specifically in a model that has trillions of locations?
Yeah.
But they're succeeding at that, right? Because they have AI and computers to support that examination. And I think that's what I haven't listened to that particular podcast or heard that term before, but mechanistic determination means how can I see where the actual mechanical process resulted in this, and where does that exist in the model, and can I prune that out of there?
Well, so I think this is a really excellent point, because so I'm gonna shift from Brian's analogy to one that we're all familiar with, which is rounding up, right? Depending on what number you're using, right? It's a 0 or a 1, right? That's
Mhm.
it can go down 5 or it can go up 5 in placement. I'm explaining decimals to people who know what this means, so I'm going to stop. But we're all familiar with rounding up. And so if I say it's $2 billion, it's likely there are some other numbers in that, but they don't matter for the context of our conversation. And
Mhm.
so that's how I see this in trying to reverse engineer what's happening. And if we're reverse engineering a rounding up, but we don't understand that, it's a very difficult path to go backwards on,
Mm.
right? Like, how did you get like 100 zeros here? Clearly it's not, right? Like,
Right.
and just being able to understand or imagine that there are processes in this that we can see the effect of, but we can't, and we can see the data going in and we can see the effect that it had, but um, trying to dissect what is actually happening. And the
Yeah.
other thing that I would say, Jyunmi, I'd love to get your take, but these people are the people who did Golden Gate Cloud. If anybody remembers Golden Gate Cloud, I think that what really? Oh wow. Okay. You're my like tech nerd AI people. Golden Gate Cloud was a tweak that that Anthropic did to a version of Claude several months ago. And I think part of what that was showing was the ability to get in and tweak something and control like what becomes more probable and less probable. Golden Gate Cloud was tweaked to make everything about the Golden Gate more probable than anything else. So you could say, Claude, give me a recipe for cheesecake. And it would say, excellent. You're going to need some cream cheese. You're going to need, I don't know how to make cheesecake. So just pretend I said the other ingredients. And you know what else you need? You need a plate on the Golden Gate Bridge so that you could consume it on the Golden Gate Bridge because, right? So like everything that you asked it about eventually led to the Golden Gate Bridge. And it was hilarious to watch it do
Yeah.
that. Um,
And
yeah.
I think it was part of an effort to try to identify, where in the parameters of the deep neural network you could place these things and have the most influence. So can you intentionally bias? That was what that Golden Gate experiment was doing. And they were also trying to look at where does that leak out to? Does that actually, end up changing other areas of the model, or is it just this one area of the model where we inserted it that it made its effect?
Right. And now you're making me remember that too, because if we can bias it, maybe we can understand how to unbias it.
Yeah.
Right.
Yeah, and I think maybe that goes to this idea. Maybe I mean I'm still trying to learn it myself, but back to the mechanistic
Interpretability.
I know. Yeah, I'm gonna get there. I always want to put interoperability. I want to always put an O in there for some reason, so I have to slow myself down. This is what's coming out of Perplexity. This is earlier when I did all this research because I was asking some other questions and again doing the brainstorming. But it brought this back, so I'll share it. It says MI, right, aims to reverse engineer neural networks into human understandable algorithms and concepts. It typically approaches this task by analyzing static architectures, studying features in circuits, examining causal relationships between components, seeking to understand computational mechanisms. So, I mean, there's a lot there. And then it goes on to talk about the growth perspective introduces several complications for MI. Networks that grow and self-organize may develop different kinds of internal representations than typically built ones or traditionally built ones. The mixing of growth and connection processes make it harder to isolate discrete computational mechanisms, kind of like what we're saying. And dynamic architectures that change size and structure during training create moving targets for interpretation. So you can see how this is big. And then we didn't even bring up this part. I'm going to bring in one of our comments here from Justin, who was responding back to Cisco. And he says, are we feeding the LLMs themselves with synthetic data, kind of like the snake eating its own tail? So we know that synthetic data is being leaned on in some ways. I don't know all the ways or how much of a weight they're given. But when you start to introduce synthetic data, I think it even further complicates. It may actually inherently make the model smarter, because it's able to train itself. But then that brings back the whole question of, but what is it training from? And was that a place of truth and knowledge and understanding? And if we're going to add synthetic data to that, how do we know that it didn't take, well, I'll say it again, a left turn at Albuquerque, as Bugs Bunny used to say, and start going down a path that we didn't realize it was going down? And then how do you unwind that? Is it as simply as going into, when I do the newsletters and I go, whoops, I made a mistake, and I go into our newsletter builder and I say, go back to the last edition or the last version of this. I want to totally go backwards, or I want to uninstall the latest Windows update and go back one because my computer is acting wonky. Is it as simple as that, or is it much, much more complex? I'd imagine it's the latter.
I want to go back to just the idea of whether AIs are consuming us or whether we're actually tending them and keeping them in their garden. And the idea of invasive species and genetic modification to plants that actually changes the ecosystem in unintended ways. That's really a perfect analogy for what we're wrestling with when it comes to the ethical considerations of development of AI that's very powerful, and more importantly has, like plants do, the ability to do influence and act in the real world, just like seeds from a genetically modified crop can spread over to a neighboring farmer's field and end up ruining the process that's happening over there. So invasive species and genetic modification, we're trying to avoid invasive AI, but there are players out there, as we know, who are working on creating invasive AI, just as there have been hackers all along who are creating malware to try to F up, the lives of other people.
Yeah, I really like your analogy, Andy, about tending the garden and whatnot, because what the concept for the show gives me this, I guess, line of thinking, right? Line of reasoning about how we look at AI. Because I think for most people, their experience with AI is, oh, I've heard of ChatGPT. Oh, it can write me this thing, right? Very, surface level kinds of things. But one of the things that we get out of this is a slightly different way to view how AI is developed or grown, right? And with that slight switch in, in aspect, or slight switch in point of view, it gets the mind bubbling on how we can better train it or better tend it, and sort of prune it into the shape that we want, right? So that's why I really like the gardening analogies, because if you've ever had any experience with like bonsai, right? So bonsai is the technique in which to cultivate the plant to get it to produce the most aesthetic result, right? So if we have those kinds of levels of not necessarily control, but where to guide our AI growth, that can result to what we're looking for. And you've touched all upon the whole, potentially being able to remove bias from the model, be able to make sure the data is valid. How will the resulting model be more and more capable for us, right? Going back to the analogy again, and the mention from the chat, it's us consuming it and it consuming us is a cyclical type of relationship, right? Mm-hmm. When the tree grows, we eat the fruit, right? When the fruit is done in our bodies, we help spread the seed, which expands the growth of the tree, and until it becomes a forest. So I think if we look at it as that symbiotic relationship, right, we can understand that we have to have a greater deal of forethought in every little step that we take, right? And being able to recognize, okay, if I make this change, it could have lasting, effect for generations down the line. And I think that change of perspective is important as we develop AI and our interaction with it.
I love that you brought up bonsai, because I feel like that is the mistake that people are making with AI, right? You look at a bonsai tree and you think it just grew that way, right? That bonsai tree is constrained in so many ways. And still, you cannot look at it and say, why did you do 2 branches instead of 5, right? Because the bonsai tree is still like in control of its own creation in that context. And I think that personally, I still think this is a little too much emphasis on how much control we're having. I understand from safety and risk and that kind of stuff, we totally want to know how to be in control. But if you are if let's say you're growing peas on a trellis, right? The little curly vines, and it's going and you are looking at the peas and you're trying to like tie them in various directions, but you're not actually paying attention to where it's planted in terms of how much sun it gets. That's a first problem, right? Like no amount of like twisties tying to a stake is going to change the fact that the sun is the primary direction that it wants to go in. So you have to understand the sun. But the second thing is, how much energy are you spending trying to get the peas to do things that you want it to do? The bee just wants to produce peas, right? Like that is so let's see how you can engage with what it's designed to do, the pea shoots, and what you want out of it. And that's one of the reasons that I keep going back to improv as a key lesson for resiliency, for change, but also for really working with AI. If you come in on an improv scene and you're like, okay, everybody listen to me, you're the cop, you're this is what has happened in the past, and now go, that's not an improv scene.
Right.
And it's not as fun or productive to watch. What's really interesting is like everybody's creating at the same time, and let's find out where we're going together. That I think is better for me. And I think that is like a great use of AI, and we spend a lot of time trying to figure out how to control it.
It's a great analogy. I mean, it's great. And once again, you've further cemented the idea that everybody should be doing improv. Whether you like it or not, everybody should have to do it. It should be part of our curriculum. You've convinced me at this point, Beth. The kids should be doing this in elementary school because it's so valuable to the ability to adapt to things coming at you. I think for critical thinking skills and all that, it must be amazing because it's training your brain to listen. You can't really do great improv if you're always in your own head about what you want to say next, if you have no idea what's about to come out of the other person's mouth or which direction the story is about to take. So, we all get caught up in that whole thing where we're going like this. We do it on the show. I mean, like everybody does it, right? You do this and you go, Beth's still talking. Okay. My turn. And then it's like, I'm not going to talk about anything Beth just talked about. I'm just waiting for the pause, So we're not having a conversation versus individually having our own moments, right? By the way, I just want to bring this up because you said bonsai and it was brilliant, Jyunmi, just like the pruning. You guys are nailing it. For me and hopefully our audience. But it also, as I heard the term bonsai with AI, I was like, well, that's got to be a company. And it is. So I just wanted to give a quick shout out to a company that's called Bonsai AI that helps you create. This is what this says their mission. It's bonsaiai.com. I just thought it was interesting. I was curious who had that name and what they were doing with AI because AI is at the end of the word. And it says our mission at Bonsai AI. Our mission is to revolutionize employee education through the power of artificial intelligence. We are shaping the future of corporate learning to create a smarter, more capable, and more adaptable workforce. So it sounds like, just really quickly on our website, that they're a website or they're an AI solution that helps you build maybe faster learning resources or learning videos. It sounds like internally learning management systems and stuff like that. So pretty cool. But you said the term and I was like, well, who is that? Somebody clearly has gotten the Bonsai AI before, you said it and I thought about it on the show. I want to just take a quick second here and just talk about this other use case that just as a business use case. And the one that I was sort of workshopping again with Perplexity was this idea of a business who's got a logistics part of their business is shipping and logistics, and where their products or perhaps parts to products are in the world. And this idea of leaning on an AI solution that is inherently beneficial to the company for a while. So this is coming back from Perplexities. It was breaking down this story because I just wrote it out. And it says the core scenario: a large consumer goods company uses AI for complex supply chain management, making thousands of real-time decisions about inventory placement, shipping routes, delivery scheduling, resource allocation. The AI system is initially performs exceptionally well, reducing fuel consumption by 20% and shortening delivery times by 30%. The crisis point: when errors begin appearing, the company faces several critical challenges. Detection complexity. Small errors compound over time. It's difficult to pinpoint where the system began making incorrect decisions. Multiple incorrected decisions make tracking the source nearly impossible. Then you have troubleshooting challenges, like, where do you go for traditional debugging? So because there's no clear line of code, like you talked about at the beginning, Beth, to examine. You can't simply undo the learning that's incurred unless you're just going to like reinstate an older version that literally wipes away. But also there was probably all sorts of millions of points of good learning that happened at the same time that the bad learning was also happening. So is there a way to wipe away just the stuff that you don't want, i.e. the pruning? Can you prune it to take away the stuff that you don't want while still maintaining something that was probably 90% effective for this company? So then you have the business impacts of like, do you revert to an earlier version and lose valuable legitimate learning? Continuing with the current version risks perpetuating errors. Retraining requires massive amounts of new data. Each potential fix could introduce new unforeseen problems. It reminds me of the show Loki with the time continuum or whatever it's called on Loki, and it's like splintering off and you're like, yeah, okay, great. Go back 5 neural network steps and tell me where you're going to start this process of fixing this. Because when you look at a neural network just on a piece of paper, everything is interconnected across, every dot is connected to the next dot. And that's on a 2D. 3D, now we have them connected in all sorts of directions. And we're not probably even talking about 3D, as we've talked about before in just vector databases. It's like thousands of dimensions. It's beyond our comprehension or ability to visualize it or make a visual of it. So if that's what's going on, how do you, without AI, without using a tool that can do this, how do you go backwards? And to your point, Andy, there are processes that are being put in place, and it was way too nerdy and techie for me. I couldn't even follow what it was saying for Perplexity, but apparently there's systems in place that are helping with this problem. But man, is it complex. And you can imagine being this business. You're like, everything was hunky-dory. It was working just fine. We love AI, right up until the point that their neural network AI doesn't start doing what it's supposed to do. And then obviously there's lots of checks and balances that need to be put in. Maybe it's a bit of this idea of the blockchain where there's multiple points of what we know to be true is being checked continuously inside this neural network. So we know that this SKU, this product, this whatever is in this location, and then continuously checking the neural network to make sure that what you know to be true is actually the answers that are coming back. So this stuff kind of just blows my mind because it's like, it's super complex. It also could be immensely helpful for businesses all over the world, but tricky at the same time.
So this is something that Andy has mentioned before in the context. So I'm going to do my probability thing, and then Andy's going to say something about it being RAG retrieval, because that's the piece that to what you're talking about, the things that we know to be true. Mm-hmm. When what we know to be true is the most probable, there's no problem, right? Because AI is going for the most probable and it's going to bring that back. When what we know to be true is not the most probable, then we have an issue. And I always say it's not doing that. It's just giving you the most probable next word. These are word prediction machines. Mm-hmm. And then Andy's like, no, it's also RAG retrieval, Beth, because there is some knowledge in it, right? Like but those two systems, would you say those two systems work together, Andy, to like make what we know to be true more likely as an answer, even when it's not most probable?
Basically, having outboard database that has a repository of curated data for a company, for example, makes it so that as a result of the prompting, the LLM is going to prefer the information in the RAG system over its inherent knowledge that it got from its mix of training data that might be probabilistically spouting some untruths because there's so many people out there on the web spouting untruths.
Right.
Right. So if you feed it, train it on all that data, then it has multiple perspectives, and it doesn't have an evaluation, a truthiness evaluation system. It's just going to, say, what is it that is likely to be the right next word for this based on my training data. But what that leads to is, erroneous and hallucinatory kinds of outputs. And so people build a RAG system, especially in company implementations, in order to say, and the promise of the companies who offer this tool say, now, you're not going to have hallucinations anymore. It's going to be founded, it's grounded information in the RAG data. But that also makes it easy for you to create a very biased LLM response. Right. So, where is truth in all of that? And we just talked on the news a couple of days ago about, I forget the name of the company now, but one that's building a machine learning architecture, the purpose of which is to do real-time validation and fact checking. Right. Find out whether this does, in fact, based on some kind of, I don't know, authoritative set of resources, does this actually correspond with truth, or is this just really what the blogosphere is spouting out there? That's part of the data.
There was a Sam Altman interview. I think he was talking to people at Stanford. Like, he goes back periodically and does talks to people. They ask him questions, like that sort of Q&A interview. And he was talking about the challenge with truth in terms of OpenAI. And it was before they introduced memory. Because he said, look, there's going to be a point really soon where people are going to have to grapple with that truth is subjective in so many ways, and you can take that as a small thing, right? Like, I want you to talk to me in metric versus what the US still uses, and I don't even know what it's called. It's Crown measures, whatever it is. Imperial, thank you. Ooh, even worse than Crown, right? Like, all right. Thank you. Or no, I believe strongly in everything that I'm going to say here is going to get me in trouble. I believe strongly in this paradigm, and therefore I need everything that you generate for me to be washed through that paradigm. And this was I feel like that conversation, Sam was really trying to foreshadow or prepare us for the way that a system needs to think about those answers, because you can't just say, I need it to be more truthful, without defining what truthful means and what's your center of truth, right? Your single source of truth.
Yeah, it's a good point. Well, I think it's probably a good place to leave off this conversation. We'll certainly be coming back to this one, like so many of the other conversations we have. They get interwoven into other conversations we're having. And, look, the whole goal of this show is everybody comes back and hopefully hangs out with us. If you're not a subscriber, please do subscribe. We're here 5 days a week. We go live at 10 a.m. Eastern 5 days a week, Monday through Friday. But you certainly always catch the replays. Now, I don't know, Jimmy, what are we up to? 370, something like that?
Close. Yeah, like 355.
Oh, okay. So maybe a little lower. So well over 300 episodes, pushing towards 400. And so there's a lot of content, but our goal with always starting this show, just for anybody who's just finding us today on this particular topic, is to simply just have open and honest conversations about it with wherever we are in the learning journey ourselves. And we're using past shows to help us inform future shows and things like that, to help just kind of make sense of what is a rapidly evolving industry and technology, and trying to figure out how that affects us, how it affects our lives, how it affects our businesses. So come on back the rest of the week and hang out. I know it is a holiday week in the States, but we plow right through. We always have somebody here. We haven't missed a day yet, in well over a year. So tomorrow we're going to be talking about the end of productivity, exploring the AI-driven future of work. So I'm really excited about that. Wednesday, as always, we'll be talking about our AI news roundup. So any of the interesting news stories that have come up over the last 7 days. And typically we don't talk about them beforehand. So usually when I'm finding out about a news story or Jyunmi's talking about something cool in science, I'm learning about it for the first time along with everybody else, as is the rest of the co-hosts. Thursday, for our Thanksgiving episode, we're going to have our AI for reflection and gratitude, which is going to be super fun. I always like having our holiday episodes. They're a lot of fun. And on a Friday, it's not the exact birthday because it would actually be the 30th, but Friday we're going to celebrate ChatGPT's 2-year anniversary. Now, just for clarity there, yes, we know that 3.2 and 1.2, whatever, all the ChatGPT models existed prior to this, but we're talking about the date that it generally went available to the public, which is November 30th. So for anybody who's a stickler on the rules and they're like, wait, Brian, wait a second, it existed before November 30th. Yes, we know that, but that's generally accepted as the date of the anniversary. Even OpenAI has talked about that date, so there you go. All right, so that's what's coming up the rest of the week. Come back and hang out with us, especially if you got a few days off. Maybe things are slowing down. It's a perfect time to come hang out. Jump in the chat, in the YouTube chat, because along with a whole bunch of other people, Cisco and Jen and Jude and all our other regulars, you can be part of the conversation, and we will absolutely bring your comments up into the show if it's in line with what we're talking about. Today, there was a lot of conversation about Taylor Swift. So that's what was going on in the conversations. And yeah, so you can always get into conversations, even if it's not what we're talking about directly in the show. All right, that's it for us today, guys. Have a great day, and we will see you tomorrow. Bye.
Aloha.